Art.
Recording is on.
Yeah, so hi everyone, we are back again. It's me and Nelson. Today we are covering chapters 13 and 14. Eloquent Ruby is still the book. So for all the previous sessions, we've been dealing with the methods that you can call on instances of a class. And what do I mean by that? Basically, you create a class and you have children of that class having methods that you can call on each of them. You define all these methods within the class and you proceed to create an instance by calling the new method on by calling the new method on the class, and then you proceed to call the method on the instance. So the topic of the discussion this time around is going to be centered around methods that are called on classes or class methods instead of on instances of a class. In addition to that, we'll be looking at singleton methods, which are methods for individual objects as opposed to many instances of a class. And we'll be looking at class variables and class instance variables and why one is preferred over the other and the differences between the two. So, like I've told you, the book is Eloquent Ruby, and page 158. I'm going to reference the code on this page for this part of the discussion. Nelson, are you there?
Yeah, I'm here.
Yeah, with page 157. So previously, this is something that we looked at in the chapter that dealt with testing. I think that was chapter 9, the one that covered the basics of RSpec. And this is a way of creating a stub object. So the author is using this as an example of a singleton, as to show you two singleton methods. When you create a stub object named stub printer and you define the available method and the render method and what they should return, these two methods are called on a single object, which is stub printer, and here you've defined what each of them should return, with the available method returning true and the render method returning nil. So when I say stub printer and I call the available method on it and it returns true, as well as when I call the render method on stub printer and it returns nil, the fact that these two methods are called on the same object and they can't be called on any other object, we can refer to these two methods as singleton methods. And this is what we are going to be seeing all throughout. So to prove that this stub printer object, we try to see here the class to which this object belongs. And when we say when we call that the class method on stub printer, we say that we get the same output, which is spec, mocks, and mock. Remember, this was an example from the chapter about mocking and stubbing. So we'll see that when we try to check for the class of this object, this is what we'll get. Instead of the printer class, where these two methods, I think, are defined in the previous chapters. So what does that tell us, and what is the conclusion from all this? We have two methods, available method and the render method. And by the fact that they are called on a single object named the stub printer, just that one object instance, and the fact that they can't be called on any other object instance, this is what makes them singleton methods.
Yeah, it's
Um,
very interesting because I had not considered the implementation details for stubbing and mocking before, but it
I
really
can't see
does
your
make
screen, Nelson. I, I don't know. I think your camera is off.
Yeah, I turned it off. My wife was walking around in the background.
Okay. No, it's fine. You can.
Yeah, she's gone. Um, yeah, but so I hadn't considered the implementation details before, but it does make sense that if you're creating this stub, this method stub, that you would implement it using the singleton method, and this is like one of the few cases where it does make sense to use singleton methods to enhance the class.
Yeah. So I think that example is pretty clear because we looked at it even from chapter 9, and like Nelson has said, even I think it's reiterated by the author that this is one of those cases whereby it makes sense to have a singleton method. So we'll proceed to I think the next couple of pages show you variations of syntax when you're defining singleton methods on a given object, and I'm going to focus on the code on page 160, which involves using the class keyword, and I think instantiating the object by calling the new method on object. Hand build tab printer is equal to object.new. Nelson, I don't know if you're there. It's page 160.
Yeah, I'm there.
Yeah. So this is going to give us a bit of a background for what we are going to see in this next subheading, whereby we are trying to see if the singleton class is actually a real class. So what we do here is we call new method on object, and then we define the available method and the render method for this hand built tab printer. And then this next section tells us that the singleton class, as you can see in figure 13.1, this more or less secret class, the singleton class, sits between every object and its regular class. So what does this mean? The singleton class starts out as just a methodless shell and is therefore pretty invisible. And then when you keep on creating, or when you start creating singleton methods for that class, these methods, they'll live inside the singleton class, so that when you call them on the chosen object instance, you will be able to get output as you've specified in the methods within the singleton class. But what we are looking at here is the fact that we are going to consider a case whereby you have a method that is a singleton method defined on an instance object that has a similar name to another method defined in the object class. So what we are going to see here is that regardless of the fact that these two methods have the same name, one is in the object class and the other is in the singleton class, when we call this singleton method on the instance object, which in this case is the stub printer, we are going to see that the method that is in the singleton class is going to take precedence over the method in the object class. What this means is that if these two methods have the same name, but they have different output, the output we are going to see is for the method in the singleton class and not the output for the method in the object class. And why is this the case? This is simply because, like the author said, the singleton class sits in between the object and the object class and the object itself. So when Ruby is executing the method call for this singleton method, it is going to encounter the singleton class before the object class. Ruby will first look for this method in the singleton class, and if it finds it, it will return the output of that method and won't look any further. So the only case in which we'll have that kind of method return output is if the singleton method is not found by Ruby in this singleton class. And if that's the case, it will look for this method in the object class as per the method lookup path. And this is what this part of the chapter highlights the fact that the singleton class exists between the object class and the object itself for methods that have names that are similar, one defined in the object class and another in the singleton class. The method in the singleton class will be called instead of the method in the object class. And then we see another example of singletons or singleton methods, which are actually class methods. At the start, I talked about what we've been dealing with all this time, and the kinds of methods being that when you create a class, you define methods within that class, and you can call these methods on objects of that instances of that class. So because you can call those methods on instances of that class, I think the name instance methods fits. Now, in this part of the chapter, we are seeing methods that are called on the actual class itself and not its objects. No, not its instances. And that is where the name class method is derived from. So you have a class method being a method that is called on the actual class itself as opposed to the instances of the class. And previously, we've been dealing with a document class. So if we have a class method being a class method for the document class, this means that we'll call that method on document itself as opposed to an instance of the document class. And that is basically it. Um, this example on chapter 16, page 162, you create an object which is like an instance of the document class, and you provide in the arguments like before, and then you're trying to check for what self is. Mm. When you run the code, when you call the explain method on the newly created object, you will see that self is the current instance of the document class, and you will see that you'll be told Ruby will tell you that the class that you are dealing with in this exact code is the document class. Now, instead of calling the new method on document, the second section of the code on still the same page, you say my object is equal to document. And then you call the explain method on document itself. And then you're trying to see what self is. And I think this is pretty much self-explanatory. You'll see that self is document, which is the class itself. And now something that is highlighted here, when you try to check for the class you're dealing with in this case. Remember previously we saw that the class was document. Now here we see a class named class. I don't know, Nelson, I think you can provide more insight into this, but as per what I know, all classes inherit from class, a class named class with a capital C.
So, I mean, generally, okay. So, I have a few things to say about all of this. Um, the first is that, like, dynamically attaching methods to instance objects, or using the same functionality to attach methods to classes. Um, in like Java, they would be called static methods, but it's basically like oh, you can call a method on the class document and without needing to instantiate a new instance variable. So you don't need to say document.new. You can just say document dot table name or whatever, and then it'll do
Yeah.
the right thing. um,
Mm.
this makes Ruby very, very dynamic. It's part of why um, the meta programming in Ruby is so good. It's because you can um, dynamically add methods, you can query methods, you can send messages to methods that you create on a single instance. Um, all of that meta programming is enabled by this kind of abilities, where where you can just on the fly modify any object. Um, oh, looks like we have somebody joining.
Oh yeah, it's Samuel.
Hello, everybody.
Hi.
Sam,
Oh, hi Samuel.
nice to be here, man. I just
Mm, nice to meet you too.
came to show some support.
So we're just talking about chapter 13 and how dynamic Ruby is, and how what singleton methods are, and uh, m- in addition, talking about uh, attaching methods to classes directly. These become public classes on or public methods on a class.
In fact, yeah. Oh, that's cool. Let me open the book real quick. So I'm not reading along currently, but I just like to be here while you guys discuss and
Oh,
share.
Okay.
it's very fine. Mm.
Um, anyway, so this like this same dynamism of Ruby makes it very, very powerful in terms of metaprogramming, but it by the same token, it also makes it very, very difficult to make a compiled Ruby, right? Because you don't know in advance what methods a class will have, because at runtime that can change. And so,
Yeah.
what are you gonna compile it to? You don't know. You don't know what this thing is gonna have at compile
Runtime
time. So
compile
um,
time.
that's why a lot of Ruby depend like that's why they've chosen to go uh, with YJIT, which is a on the fly just in time compiler, and that just in time compiler can compile the Ruby code that we see into bytecode that can then be interpreted by uh, like a yeah, by a virtual machine, is what it is. And those instructions go through the virtual machine. So yeah, I've sort of lost my way. I to bring it back to this chapter. Um,
Mm.
the In terms of these singleton methods, generally, like even the author says that most Rubyists think of them as like not very useful. I mean, they're useful when you're doing metaprogramming, and uh, you do a lot of metaprogramming when you're writing libraries. So they're great for writing libraries. The When I've used them personally is when I'm refactoring some code, and I'm like, let's say I have some code that I'm calling in my view page, and I want it to work a different way. And so I'll just test whether or not it'll work by just dynamically like adding this method in my views, and seeing if it'll work. Like, does it work if I make this method go this way? And then if it does, then I'll think about, okay, well, I have to do a big refactor, but I know that if this object has this method, it will work. Okay, cool. So what do I need to do to change this object so that it doesn't break any code anywhere else? And so it's super useful in terms of like on the fly changing your code to test out if some new feature will work, and then helping you plan out your big refactor.
I see. Sounds really useful.
Okay, so I sorry, you you can take the mic now.
No, it's fine. I love actually listening to this because to me it's more like theory. I don't know where most of these things apply. So conversations like these are very enlightening for me. So I don't know. Hey, I had asked you about the class. All classes inheriting from class. The class named class.
Oh
Is
yeah,
it? Yeah.
yeah.
Because to me it seemed very confusing.
It's um yeah, like all those are implementation details of how the C code works. Because um, you have something in Ruby. Like a lot of this is detailed in a book called Ruby Under the Microscope, which I've taken a look at, but I haven't actually read completely. I only read like the first one or two chapters, and I didn't get very far into it. But when they're talking about, oh, everything inherits from this something called class, or something called object, it gets a little convoluted in terms of what they're actually referring to, because um, the implementation details of the Ruby uh, interpreter differ from our understanding of, or abstract understanding of, the Ruby language itself. And so when they're referring to, oh, everything inherits from something called class or whatever, they're referring to the implementation details of the Ruby interpreter, and not uh, the code that you're seeing or the code that you're writing, right? Because you're think yeah, like it's
Okay.
two it's the same terms for two different e- environments entirely. One is the code that you're writing, and you like the code that you're writing, you can think of it as like, oh, I'm writing a class, and this class inherits from object, and you don't really have to know very much beyond that. um,
Yeah. Yeah.
versus if you're modifying the C code, then in the C code you have to understand, okay, well, I have this instance is inheriting a singleton class. That singleton class is inheriting from object, and object inherits from class, or yeah, something like that.
Oh yeah, I've heard of a basic object.
Yeah,
That book called Well Grounded Rubist. I read something about basic object. I think it's also one of those things that you've talked about.
yeah, there's a whole hierarchy of things that inherit from other things, and
Mm.
um, it's good to know. I don't know them like uh, like very well. I know that they exist, um, but when you're writing Ruby code, you don't really have to think about it. When you have to think about it is when you're trying to write a very, very performant code, and then it matters, because then you're like, okay, well, I'm not going to use a string here. I'm going to use um, a symbol, because symbols are atomic. Strings need new memory allocation for every different string, and symbols are a single place in memory uh, uh, that you don't need a new memory allocation for. And so, okay, well, because I know that if I'm using a hash, then the keys for my hashes shouldn't be strings, they should be symbols, because if I put a string in as the key, then it requires a new memory allocation every time I I create this hash instead of all my keys being symbols, and now I have a hash that performs better because I chose uh, symbols over strings. And you can start thinking of those optimizations in your head, but it's because you have that detailed knowledge of the implementation details under the hood. Um, but to make a to make a code that works, you don't need to know any of that.
Eh, okay. So thanks for rectifying that. I think the rest of the stuff is pretty much self-explanatory. We've seen that class methods are methods you call on classes themselves instead of instances of a class, and that was the highlight of the second section of this chapter. So in the wild, Nelson mentioned the table name method that you can call on an active record class. That is an example is shown on page 164. You can look into that. And I think it's going to return authors for this case. Author.table name, you'll return authors because that will be the name of the actual table. And then other class methods, you can say there's a civil method that you call on date, the date class, and then the ordinal method. And these are like I think methods that allow you to create dates of various types. So you can look into those that are available for the date class. Then Nelson talked about this thing of star being one of the most practical applications for singleton methods, and that is something you look at when you're writing tests. So yeah, that is definitely something to check out. Yeah, and I think we proceed to chapter 14, Nelson. Except if you have something to add on to that.
No, we're we can move on to the next chapter.
Okay. So
Oh,
all this time,
one thing I will say is that like um, in your production code, if you're using uh, singleton methods to and attaching them dynamically, you're gonna confuse your other programmers who are reading it. It's like a very convoluted thing to do. You probably shouldn't do it in your production code because it's unless you really really need to, and you only need to if you're doing metaprogramming, which is like creating some libraries or doing like or for in my case like I only do it when uh, I'm like refactoring code, and it's just a tool for me to figure out how to change the code, but I don't commit it to production code. Okay, chapter
yeah.
14.
So yeah, chapter 14 now. So previously, the highlight of chapter 13 was methods that you call on classes or class methods and singleton methods, which are called on individual objects. Chapter 14 will look at how we store information in classes. Information that is related to the actual classes themselves and not instances of the class. And here Ruby provides us with two options. One of them is class variables, and then the other is a class instance variable. So what we'll look at first is the class variable, and then we'll proceed to see class instance variables, what these are, and why class instance variables are preferred to class variables. So I'll begin with a quick refresher. Why do we need variables? Variables are basically ways of storing data that we may need at some point later on within the application or outside the application. We use a variable to store that data. Previously, we've been dealing with instance variables, whereby you have, now let's say, an initialize method that is inside a given class. Now let's say you have a class named person. In its initialize method, you have a name instance variable. So what this variable does is that it just stores the name of the person when you're creating a new object, and basically that's all it does. It stores the name. So if you need to, maybe, I don't know, turn this name into maybe uppercase, or maybe you capitalize the name, you can access this name through the instance variable. So an instance variable is a way of storing data that is unique to to an instance of a given class. So this brings us to a class variable. A class variable, like I said, you use a class variable to store data that is specific to the class. And how do you define a class variable? You define a class variable with two at symbols instead of one. So you use two at symbols, you write the name of the variable and then the value of the variable. That is a class variable. But then, according to page 171, the subsection is called wandering variables. This goes into a lot of detail, but I'm going to try to summarize. What we see here is that you have a class, and then you have subclasses that are inheriting from that mother class. So what you're going to see is that class variables that are defined in the mother class can be accessed by the subclasses themselves, and therefore overwritten by operations that you're performing in the subclasses. And basically what this might result into is that, now let's say you've stored data that you need to be in that mother class and you don't need it to be changed. If you have subclasses that are getting access to that class variable, and therefore the data, and the data is being changed, at some point when you try to access that data, you're not going to be getting what you expect from the mother class, because down the hierarchy, these subclasses were able to modify the data that was stored in the class variable. So you're losing data. That is like the bottom line. And this brings us to the reason as to why a class instance variable is preferred to a class variable. For class variables, the state is shared between the mother class and the subclasses, which is not the case for a class instance variable. So if you have a class instance variable in the mother class, and then other class instance variables, even if these variables are of the same name, the variables in the subclasses are not going to have access to the data in the mother class, and therefore you won't override that data that you've stored in the variables. And this is basically what this chapter is all about. You're going to prefer to use class instance variables as opposed to class variables, because of that unintended data loss that is related to class variables having a shared state between the mother class and the subclasses or the child classes that inherit from the mother class. That is basically what chapter 14 is all about,
Yeah.
in summary. Yeah.
Um, let me see if I can share my screen here. Oh, I have to select a tab to share. Okay. Can you see my screen?
Oh, yeah, yeah.
Yeah. Okay. So this is what he was talking about when you're running into problems here. Because let's say you have this resume class that has the default. It has this class variable called default font that is set to Arial. That's great. That'll work. Your default font for that resume will be Arial. Fine. Then you also have another class called presentation, and you set that as the default font equals Nimbus. Um, and that's great, and that'll also work. The problem is that you expect your resume to be Arial and your Nimbus to be, or sorry, the default font here to be Nimbus. But if you create, so if you inherit from a document class, and within that document class, you also set um, the default font variable. Whoops, that is not what I was expecting. So at default font equals times, let's say, then you run into this situation where you have unexpected things happen because you're at first you were expecting your resume to be Arial, but this is now that you've set default font here, it's no longer going to be Arial. It's going to look for when you're instantiating a new class, you might end up with like times here instead of Arial. Uh,
Yeah.
so there are little like nasty edge cases that you should be aware of, where you really if you have a hierarchy or you set up an inheritance tree and you're using class variables in your inheritance tree, well, you might run into things that you don't expect. Okay, let
Oh,
me
interesting.
stop sharing.
Yeah, I think uh, I think that's pretty much it. The the chapter 14 mostly deals with that, and that is something to note when you don't want to run into that kind of thing whereby you're expecting something else and then you actually have something else returned to you. So yeah, Nelson, are we on time this time around? Are we
We're
being
finally on time. I will say that the large inheritance trees, like they that's not the only problem you can run into. Like last time we were talking about classes and subclasses and how like the book was recommending that you limit your use of them. I think I was recommending that you limit your use of them. um, and it's because when you run into when you start trying to create a large hierarchy, it makes your code a lot harder to change, and and it's not as flexible. You know, you want your code to be um, uh, as flexible as possible because you cannot predict the future, and so you need to be able to change dynamically depending on new project requirements that are given to you that you have no control over. Which is why you should prefer composition over inheritance. And actually,
oh, the module thing?
yeah, a lot of
Okay.
people conflate object-oriented programming with, you know, you know, having classes and subclasses on those subclasses to create a hierarchy of a classification of the world. But the original creator of object-oriented programming lamented that his ideas had turned into that because his ideas were all about originally were all about message passing, that one object should not know the internal workings of another object. It shouldn't care about the internal workings of another object. What it should do is send a message whenever it wants to complete some action. If some object has a method attached to it, then we can say, "Hey, other object over there, uh, can you say hello?" and then the other object, goes and says hello. Um, but it has nothing to do with creating a huge hierarchy of a taxonomy of the world.
All right. So I think this is it, Nelson.
Yeah, yeah, we're finally on time.
Kamal, do you have anything to say?
Uh,
Um,
yeah. So I wanted to ask about those class variables. So I think that's like a blind spot I have with Ruby because I've not really used them personally. So I wasn't able to follow when you were explaining that you could get, um, will I say, non-deterministic results using them. And with those font types, you could get something else instead of times. And though I didn't really follow that, could you like explain again?
um, I think I'm trying to find the page because I think it was in the book itself.
Yeah.
Um,
Also, I rarely see or rarely get to use class variables in something like Rails, for example. And I wanted to ask, like, why is that? It seems like it's not needed as much as instance variables.
Oh, I think the chapter is 175 at the very end of the page. That's where that example is. The
175.
one for the font.
Okay. Uh, oh, I see. Okay.
yeah, but you're right. You don't really interact very much with class variables, um, and I mean, I don't think so. Like in the wild, the places where I have used class variables was like trying to understand what my code was doing because it was being very very slow, right? And it was being very slow because it was sending some requests to the database. So I was like, okay, well, how many requests are actually being sent to the database? Um, and so every time I would send a request, I would add one. I would increment a counter that was a class variable, and so everywhere my code was used, or everywhere it was like trying to connect to the database, I would say, okay, plus one, plus one, plus one, and I was expecting that the code would send like at most 100 requests, but it ended up the class like at the end of the operation I printed out the class variable and I found, oh, it's sending 10,000 requests. Okay,
Whoa.
well, something is broken. And I could have achieved this a similar thing by using other tools like your server logs might be able to tell you like how many requests are incoming or whatever. But I was interested in that class specifically because I knew that that was the source of the slowdown. There's also tools that you can install that will let you see those things on the fly. Um, Rack Mini Profiler is the name of one of those tools where you get a visual interface at the top of your screen that tells you um, basically like uh, like how many requests were sent to the database. But this was something that I was just like doing on the fly. I was trying to figure things out interactively using my own code, and I was able to see, oh, okay, this class variable ended up storing the number of requests and it was way more than I was expecting. So, okay, let's see what's going on. And every time I made a code change, I could see, like, okay, now how many requests are happening. But it was something that I did on the fly and I did not commit that code to production. Um, and honestly, I think the reason that you don't see class variables used more often is because they are global state. And global state is very dangerous because anywhere in your code can call global state. And if you rely on a variable being one thing, but then it gets changed from a whole separate part of the application, ooh, good luck figuring out what code changed your variable. So
Mm,
it's you know it's really easy to use, but it also comes with this massive foot gun that all of a sudden you have global state that could be modified by any class anywhere, and that makes the your code much harder to debug.
I see. All right, that makes sense. Sounds like an
Yeah,
interesting.
Samuel,
Sorry, what'd you say?
Samuel,
Yeah.
I have an example for you though. I don't know. So do you
Okay.
want to see it?
Yes, please.
Yeah, it's kind of a simpler version of the whole. I think it will help you solve your thingy, your question. I'm trying to screen share.
Okay.
Yeah. So I don't know if you guys can see.
Let me see.
Can you see
Um.
my these notes are in my Obsidian vault. I don't know.
Yes, I can see
Nelson, you
them.
Yeah,
can see that?
yes, I can see them. Parent and
Yeah.
child.
Yeah. So I have a very pardon?
Parent and child classes. That's what he said. You can go on, please.
Yeah. So this is kind of like a very simple example. Yeah. So I have a parent class and the child class, and child inherits from parent, right?
Okay.
So what we're trying to do here is that we're calling increment, which is a class method that is defined in the parent class. We are calling it on parent first, and then we are calling it on parent again. Yeah.
Yeah.
And then after we are calling it on child. Yeah. But then you see that the child class doesn't have an increment method defined inside it, but rather this increment method, it's accessing it through the fact that it inherits from the parent class, right?
Yeah.
So when you try to count here the total, remember when you call increment in the parent class, given that here you call parent dot increment, the increment method on the parent class, you're going to add one to the counter, right?
Yeah.
Yeah. So you add one to the counter and the number changes from 0 to 1 when you look at the very first increment colon parent, the parent class, right?
Yeah.
Yeah. So your count is no longer 0 but it's 1 because you've called the increment method once on the parent class. So you call the increment method again on the parent class. This is the second time now. Yeah.
Yeah.
So the count changes from 1 to 2, the total count that is stored in the count class variable.
Yeah.
So the third time you call increment method, instead of calling it on the parent class, you call it on the child class. Now this is where it gets interesting. The child class doesn't have the increment method defined inside it, but rather it accesses it through the fact that it inherits from the parent class. So when you call child.increment or the increment method on the child class, Ruby is going to look inside the child class and it's going to find out that the increment method is not defined here. So it's going to look to the parent class. Yeah.
Yeah.
The
Going up the.
last count is 2. Remember from the previous calls of the increment method on the parent class. Your current count is 2. But given that Ruby has found the increment method available for the child class through its parent class, we are going to change the count from 2 to 3.
Yeah.
Yeah. So now when we try to return the last count, when we call the count method on parent, instead of 2, because we called the increment method twice on the parent class, so that is, we are supposed to see a count of 2, we get a count of 3 instead of 2. And basically what this tells you is that this very last call of the increment method on the child class got access to the count class variable that is defined in the parent class and changed it from 2 to 3, which is why you get a 3 instead of 2 when you try to return what the final value of the count is. Yeah.
Yeah.
And
I
then
see.
when you call the count, when you try to access the count class variable, now by calling the method on the child class, you see that the value is still 3 instead of 1,
Yeah.
simply because these two classes are having access to the same count class variable, and that class variable has a value of 3, which is
Yeah.
why you're going to have 3 returned in both cases. I don't know if that clarifies your question.
Yeah. I feel like I follow this example, but it sounds to me like what Nelson said earlier, where
Yeah, yeah, it's the
maybe
same thing.
you were doing something with the parent class and you really wanted to uh, maybe pay attention to the count variable and you
Mm,
depend on it. But uh, another class somewhere that inherits from parent can call that and access the same variable. But the question I wanted to ask before is it only classes that inherit from parent that can access this? Because
oh, I didn't quite get the question.
okay, so it's only what classes that inherit from parents that can access the count variable, right?
Yeah, yeah, yeah.
Okay, something in the other example made it sound to me like it was any class in the code, so I was a
No,
bit
no,
confused.
no. All those classes inherit from document. Document is like the mother class. Yeah. I think Nelson,
Oh,
that's what you were trying to show.
oh, I
Yeah,
see. That makes
Document is like the big class. Yeah. So you have a presentation is a document and a resume is also a document.
oh, I see.
Yeah. So
I
they
see.
are all subclasses of document.
So did the oh, but the default okay, the default font was it the class variable? Was it defined in document?
Default font. Yeah. Yeah. It was defined in the document class. It was defined thrice.
yeah,
Once in the document class and then in the subclasses, then there was a presentation has a different font, and the resume has a different kind of font.
Oh, I see.
yeah.
All right, that makes
The example wasn't one that I made up. It was the
Yeah.
example from the chapter.
from in the book. Okay, I
Yeah,
see.
Yeah.
All right,
Mm.
that clears it up for me. Yeah, thank you for the example.
Yeah. So I think this is it.
yeah. The recording is going to end really soon because we're going to hit the 1 gig limit. So
Okay.
I'm gonna I'm gonna go ahead and
But we are done. I think we are done.